Okay, hello. It is 4:30, but not many people are here. And I can think of a couple of reasons for that. One is that everyone who intended to do senior and open back to back has given up. And therefore, there's a big chunk of people whose brain has decided to go on extended leave. I'm not sure whether all the Hwa Chong people are done yet, but I would also understand if they are not ready to be joining. So we will see how many more are going to join in over the next few minutes. But anyway, welcome. And I am sorry if I have ruined the start of your June holiday. Uh, there are some of you who are like, teacher, I finally finished all my exams. My exam results were pretty good, right? Then I was quite happy with like the physics Olympiad and chem Olympiad, and I was feeling very good until I tried your hard SMO. Then after that, I felt very sad. Um, sorry, um, it is hard, right? And I am trying to get separation between junior, senior, and open difficulty. So it kind of is that I set junior first, and then I need to make sure there's sufficient gaps between them, and so it is meant to be difficult, but I don't really like to say that it is unrealistically difficult in every sense. So like the other videos, we will just start by acknowledging what I'm estimating as the cutoffs, which are the same as the ones for senior. This is my estimate based on the scores that I have seen in the submissions. If anything, maybe it is plus minus one or two is quite easily possible, right? It's the sample size is nothing like the SMO, so I don't know what will be the percentages that they are looking for in terms of like honorable mention and bronze and silver. No one really knows. They don't reveal it. The difficulty of the paper is as follows. Number one, there are easy problems. But the easy problems seem to be very time consuming and also very mistake prone. I think that this is one of the papers where I got a very big differential between expected score and actual score. In the form, I asked you guys to key in your expected score, and sort of like the expected minus the actual was usually going to be around like 3 points on average. That's quite a lot, considering that I mean it's not 3 out of 25, right? Because I know some of you who just wanted to express your frustration and just said that your expected score is 0. I didn't include those, but otherwise it's quite a significant differential because a lot of the easy questions seem to be like, how do I not do this by listing? But then after that, when I do this by listing, I am wrong. So I do not like to set questions which have no clever method and no shortcut. Uh, I always set questions to have some purpose of existing, but it is true that finding those shortcuts does make the question a bit harder, meaning solving the question with that shortcut is not obvious, but it will save you a lot of time and it will also reduce your error likelihood a lot. Now, another issue is just that a lot of the questions cannot even be classified cleanly. There are a whole bunch of weird combinations of topics, which means that, let's say, if you are comfortable with algebra but not with number theory, or combine but not with geom, then some of the questions there are hard because of one half of the pair of ideas. Open does this a bit more than junior and senior in terms of mashing together ideas, but on average, a bit less than I did in my paper. Number three is just that I have Combi, Geom, and NT all represented. which is perhaps why everyone finds it hard, because there is something among this that you don't like. The chance that you like algebra, combi, geom, and number theory all equally is very low. And therefore, there will at least be a substantial number of questions which you are like, oh, this is really hard. Now, also, I am actually actively coming up with questions which I know are not going to look like the past SMO questions. When we go through them, you will find that many of them actually use overlapping ideas with the past SMO questions, but it does not look like it. Which means that there isn't anywhere, oh, this is just like the question from 2021, this is the question from like 2 years ago. You don't have too many of that. That also makes it difficult. Now, if I'm being honest, I know that it is basically impossible to finish the paper in time. That is how I feel a paper should be for SMO Open. Right? Round 1 should actually have separation, meaning that it rewards you for your ability to solve questions. It also rewards you for your ability to do them quickly. That is not always the case if you look at the past year papers. There are past year papers where there is a non-zero chance that some people can actually try all the questions. I'm not talking about solve all, I mean just properly attempt all. There are some years where you get sort of like 8 or 9 questions that can be solved in 2 minutes, and then after that, that buys you a lot of time for the rest. I didn't really do that here. So that is going to naturally make things pretty hard. Okay, so as we go through the questions, for those of you here, feel free to just ask anything in the chat. If I forget to respond to you, then just wait a little, because I am also focusing on making sure I explain the questions properly. And another thing is that the playback will still remain up on the channel until well, I mean, it will just remain on the channel unless my channel gets deleted. So it will remain up there. You are welcome to try the questions that you have not done. If let's say that you're watching this on recording, just pause it and try the questions if you want to. And also, if you're watching this live but you need to rush off for something like you need to have dinner, just feel free to step aside. Okay, I expect that we will be finished sometime close to around 7:15 is my estimate. Okay, so without further ado, let us begin. Question 1. Already, it's like, yeah, why make me do this? I don't feel like doing long division, and then you get the 23 cube. Why do we have to start with 23 cube? Okay, let's not start with 23 cube. Let's start by letting m equals to n minus 10 and substitute first. So now your expression is just this. And so you don't need to expand in full. You just need to get the constant term at the top. There's m cubed some stuff, and then minus 13 cubed plus 2026. Right? So the only calculation you do here is of 13 cubed, which is 2197. Which means that for this to be an integer, I'm sorry, I forgot there's the dot dots again. Some stuff which I don't care about. For this to be an integer, it means that m divides 171. Now, the thing is that this is the sum of all integers, right? Which means that n can be plus or minus. So m can also be plus or minus, which means that actually all the m sum to 0 because they cancel out. And if the sum of the m's is 0, you know that n is just 10 plus m. So your answer, since all the m's cancel out, it's just 10 times the number of factors. But don't forget that the number of factors includes both the plus or minus. So 171 is 3 squared times 19, which has 3 times 2 or 6 factors that are positive. And then plus times 2 for the sign gives you 120. This is quite an obnoxious question 1, meaning that it is entirely possible that some of you spend 10 minutes, 15 minutes on this question because of listing everything. There should be a purpose to how the questions are set so that you don't have to just list unceasingly. Okay, question 2. Sum of all x that satisfy this. Basically, sine 6x plus cosine 4x, is there a sum to product for this case of sine plus cosine? Then you think about it, is there a sum to product for sine plus cosine? Don't have. So just change the cosine to sine, and then you will have. Right? Cosine is sine of the complementary angle. Okay, so we can use our sum to product. And apply it to the left hand side. Okay, so now then you are like going to just grab when sine is 0, you know that it's multiples of 180 degrees. When cosine is 0, it's 90 degrees plus multiples of 180. So this can only give you one solution, which is 135 degrees. This one, I think the easiest way to write it, although you can list, is just to say that it is 90 mod 180. You can write it as 135 degrees plus k times 180, where k is between 0 to 4. You can say that. Prefer to write it like this just because it's a bit faster. Okay, so 27 mod 36 gives you these as your solutions. Don't forget that the 135 is repeating. This is not a trap, this just is what happened to occur from doing the sum to product. So don't double count that, otherwise this is just arithmetic progression. So 5 times 99 is 495. You're going to see that one of the things about the SMO Open, right, it's that it is testing you on your general like efficiency also. Your general efficiency is kind of like you know, the annoying summary writing that you remember from English either recently or years ago, depending on what year you're in. It's like with more vocabulary, you have the ability to summarize the sentence using fewer words, right? Then you got the irritating word count to try to fit in 15 points. SMO Open is like that, right? The more different like so-called equivalent conceptions you have of something, like the more you're like, okay, do I do it directly or do I substitute? Do I do it by writing in terms of some parameterization, or do I write it in terms of mod? Like once you know all of this, it just gives you more ways of writing your workings faster. And like let's say, oh, it's an AP, so I don't have to just do addition. I can just take the median times the number of terms. You know, save 1 minute here, 2 minutes there. It really adds up. Okay, number 3. The idea for number 3 is that you can choose to group them in this way. Because you know that most of these are going to be very small, right? That is, you took the square root, you round down first and then you square. So it basically means round down to the nearest square number, right? That is what it's doing. And the nearest square number is not going to be too far away. So how does this work? Well, it means that you're going to end up with, let's say, from 1, 2, and 3, you're going to get 1 minus 1, 2 minus 1, and 3 minus 1. And then when you reach the next square number, then the floor of square root of 4 squared is, well, 4. So it's going to just look like this. And then after that, it resets again with every square number. So it means that it's 0, 1, 2, 0 to 4. Where do you go until? So the only computation you really need to do is what is the nearest square to 200, which is 14 squared is 196. So which means that the last block would end at 13 squared to 14 squared minus 1. And then the last few from 196 to 200. So this is just like sort of an extra block because of the little bit of overflow when you reach to 200. This is 10. But otherwise, what you have is there are 13 blocks of sum from 1 to 2n. Well, 0 to 2n, whatever. Sum from 1 to 2n is 2n, 2n plus 1 over 2. And then you can handle the summation. This is weirdly quite similar to the thing that we had in the senior paper, right? You'll see that, hey, this computation, I feel like I just saw this for some of you. Well, you probably indeed just saw it. Okay, so don't forget the plus 10, and you end up with 1739. Okay, question 4. Question 4 came from me trying to find a way to set a question where the answer was 2026, but failing. And then I thought, never mind, it'd be kind of funny because I'm sure that somebody will just guess 2026, and in the end, a lot of people guess 2026. So, well, it is not 2026, it is 2023. The question again is very complicated sounding, but it's just two sets of concentric circles, right? Two sets of concentric circles. So it means that you have got a line where it goes from 1, 0 to 45, 0. You have got all the integer points in between from 1 to 45. You just gotta mark them out. And so on. And then you are just drawing a bunch of circles centered at this side. I'm not going to draw that many, right? But you have got these two sides and you are drawing some circles until you reach the other end. So your task is, can you be able to count the number of intersections? Right? Number of points that lie on at least two of the 88 circles means count intersections. It is obvious that, at least based on the way I've drawn it, the green circles on the left are not going to be intersecting with one another. They are concentric. It is obvious that the yellow circles on the right are also concentric. They are not going to intersect with each other. So the only things that you need to worry about are the green circle intersects the yellow circle. How does the green circle intersect the yellow circle? Well, if it intersects gamma n intersects omega m, if n is greater than or equals to m, right? So that the circles on the left are big enough that the point they pass through, if let's say that this one passed through down here, and then after that this one passed through down here, then yeah, then they will meet. Therein lies the small trap, because unfortunately for you, if n equals to m, there's one intersection because they are tangent. If n is strictly greater than m, then now there are two intersections. That's the one and only trap. So the one intersection, because this is going from 2 to 45 and 1 to 44, right? I am not going to have a circle that goes through itself. So that's why it cuts off there. So the overlap is from 2 to 44 is 43 points. Every time for counting questions, be very careful of the off by ones, because that is the most likely thing to go wrong, even if your overall method is correct. If you do coding, you know every time your loops are off by one in lots of places, and that is the culprit. So for counting, same thing happens. Otherwise, basically, if n is greater than m, n is from 1 to... Sorry, n, the first n here is from 2 to 45, the m is from 1 to 44, means that I basically just need to have 45 choose 2. Because every pair of them, the bigger one goes to n, the smaller one goes to m, but times 2, right? Just two intersections. Now, it is very clear that none of these will overlap, because you cannot have green, and yellow circle go through the same point. The green circles already don't intersect. So you do, and likewise for the yellows, if you want to sound posh, you can say that's by pigeonhole. But essentially, it's just that you don't have to worry about anything other than counting intersections like this. Okay, question 5 is a binomial theorem question, twisted slightly differently such that it now becomes a number theory problem. What is the smallest positive integer value of k such that this thing has a non-zero x to the 2026 coefficient when expanded? we know how the binomial theorem works. We're not interested in the actual coefficients. It's just that, I have a total of k things. So if I have a total of k things, then I am going to have some number of both terms. Let's say this to the power of a, this to the power of k minus a. That gives me the 2026. Right? This is how it's supposed to work, which means that you get 37k minus 18a is equal to 2026. So it's really a Diophantine equation. I need this to be true for some a between 0 and k. Right? That's how the Diophantine works because it is from the binomial theorem. Your a cannot be negative. Therefore, what I want is the smallest k such that a exists and is positive. So to make sure that a exists, 37k minus 18a is 2026. I can take mod 18. That would ensure that a is an integer. And 37 is 1 mod 18. Again, chosen to be nice. So you can see that k is congruent to 10 mod 18. Of course, the other thing is your k needs to be big enough. You cannot just let k be 10. So if you just take 2026 divided by 37, what you will find is that you get a total of 54, remainder 28. So k needs to be at least 55. But then of course k is 10 mod 18, and 54 happens to be 18 times 3, right? So the minimum k is 50, is 3 times 18 plus 10 equals to 64. Yeah, I try not to dwell too much on the computations, but yes, a very real issue is doing these calculations without a calculator takes time. You're not going to also greatly improve your calculation speed in the next 4 or 5 days. So just work at your pace, right? Don't rush until you make all kinds of calculation errors on like addition, subtraction, multiplication, and division. Go at a comfortable pace with a sense of urgency. Don't just, I don't feel like doing long division. Do it, but do it carefully, because you don't get method marks. You don't want to lose precious points because of these kinds of issues. Okay, so same as also for the junior and senior videos, because of Microsoft Word tends to lag after being open for too long, I've split it into blocks of 5 questions so that it will hopefully be a bit smoother. My writing won't get worse and worse, and I won't get out of sync between my audio and my writing. So I split it up, and we will continue probably until question 10, so the second set of 5 before we take our first break. Okay, question 6. Gx is this polynomial, and fx is a polynomial as well, such that g of f of x is this. Equivalent ways of thinking about this is that, how do I match fx? G of f of x is literally fx squared minus 4fx minus 21, and I want it to look like this. it is pretty obvious that means that fx should be some quadratic so that there's a power 4. But I'm a bit lazy to go and say, okay, let fx be like a quadratic and then like determine the coefficients by comparing. It feels a bit slow. I can see that this is factorizable as well. I can see it from here or from the original quadratic. But also a little bit lazy to go and try to factorize this quartic, right? Because it means that therefore this thing should be factorized. I don't feel like factorizing that either. So we won't do that. I think the easiest way is probably via completing the square. That requires the least amount of guessing, because it just means that if I add 25 to this, this is what I obtain. And if I know that this is a perfect square, that's another thing. That's not very hard to factorize anymore, right? When I know it's a perfect square, I know that this starts with an x squared. And then I can compare the next coefficient, like how we normally complete the square, minus 4x. And then I know that the last one is going to be plus or minus 3. In fact, it will be just plus 3 because of the last coefficient here being minus. Okay, so this tells me that fx minus 2 equals to x squared minus 4x plus 3, and then you say, hey, hang on, wait, what? F of 2026? That's too big. Right, wait. Of course, that is not the intention, because the intention is that now fx minus 2 is plus or minus this, and I chose 2026 just so that you will be alerted to the fact that it's not just the positive case. So there are two possible f's, and obviously it means that the two possible values of the plus or minus that thing will cancel off. So that cancels off, it's just 4. Yeah, so when a lot of students complain to me that the paper has so much computations, how are you supposed to do it so quickly? I know why you're saying that, and I know that if I were taking it as a student, I would definitely be doing some of the unnecessary calculations and also get quite annoyed. You can afford to do some of the annoying calculations. You can't afford to do all of them, right? Then it would really take way too long. Okay, question 7. A, B, C are roots of this polynomial. There exists a z such that, so this is just the answer extraction put in the middle of the question, right? It's just there exists a unique z such that this is equal to 0, find z. This is not factorizable, clearly. So it is very obvious that you are not going to be able to find A, B, and C. Now, you kind of want to use Vietas, which we can very quickly write down the statements that are implied by Vietas. We can write down Vietas, but then, okay, what does that have to do with anything? There's cube roots of z minus a, z minus b, and z minus c. What does that have to do with everything? Yeah, I would say straight up that this question is probably the hardest question in the first half of the paper to me. Because it looks like Vietas, it smells like Vietas, but there is a pretty clever and unexpected trick that we can do. I'm going to call these things PQR. Right, so the equation is just P plus Q plus R is equal to 0. That's what is given. Now, basically in reverse of the senior thing that we saw just now, I'm going to use this to upgrade up to my cubic identity, because what I would like to do is to find an easy way to cube all of these, right? So, I mean, you could technically have written it in the form with all the cube roots, but I think it's easier to see like that. And I wrote ABC, PQR, not ABC. So P cube plus Q cube plus R cube, I am happy with that. I'm very happy with that because I know what A plus B plus C is. Am I happy with that? Actually quite happy, you know, because here's the trick. The trick is that, yes, I could expand this again, but again, to save time, you could say that you do know when I say A, B, C are roots of the polynomial, it means that this is the factorization, right, of the polynomial. It's x minus A, x minus B, x minus C. If you know that, then z minus A, z minus B, z minus C is just this polynomial in Z. This left-hand side is just 3z minus A plus B plus C, which is 20. Okay, so that's the nice part. The admittedly not so nice part is that, okay, so what do I do with this? I know that I can just cube it because the leading coefficient of 27z cubed will cancel. So I'll be left with a quadratic. And I also know that it says unique, so something good will happen in that quadratic. It will be rational. It's not going to be some horrible ugly root. So I will just cube the left-hand side. That's the only part of it that is a bit more ugly. Okay, so 3 times 3 squared times 20. 3 times 3 times 20 squared. And then 20 cubed. 27 times of that. So you see that, oh, actually the z squared also cancels out. Again, more good news. It's just a linear equation. Of course, the linear equation, not terribly exciting to solve. So I will just give you the result. It doesn't simplify, it just gives you two things that are very co-prime to each other. So admittedly, the last step is a little bit more messy because of the computation, but you really did not have to make any mess prior to this. This is a common trick, this thing about realizing that when you have roots, let's say ABC, and then you have got x minus A, x minus B, x minus C, don't expand it out. It is literally the polynomial is x minus A, x minus B, x minus C. Okay, so the point is that the reason motivating this identity is I'm happy to cube them and I am happy to multiply them. Hence, this thing makes a lot of sense. But like I said, I think this is the hardest question of the first half. Okay, question 8. Triangle ABC, AB is 20, BC is 26. What is the smallest positive integer length of CA such that these things form the sides of a triangle? In other words, your triangle inequality. No. triangle inequality stuff can be annoying sometimes because there are different cases, right? It's like, I need to know which is the longest side because the triangle inequality is the longest side is going to be less than the sum of the two shorter sides. Thankfully, don't have to worry about that here because clearly this is the longer side due to the 1. Okay? The other two are less than 1. So, one nice feature there. So let's write it down. Cosine squared A plus cosine squared C must be bigger than 1 plus cosine squared B. Now, what I would like to do is to ask myself, how do I do this without a massive cosine rule bashing? And the answer to that, I prefer the sine rule. Because if I have sine A, sine B, and sine C, it's just proportional to A, B, and C, which is very easy to transition. So compared to the cosines, which I don't really like. Therefore, just switch all of them to sines. The ones will cancel. The negatives just flip the direction. And then from your sine rule, because of the fact that they're proportional, it just gives you a squared plus c squared is less than b squared. Yeah, so then you just, this is 20 squared is 400, 26 squared is 676. Nearest square number above it is 33 squared is 1089. A lot of the questions therefore follow the model of one observation and then one like so-called procedural computation. If you sort of went straight to the ugly computation, you know that for SMO round 1, it cannot be so bad, or at least if the question really is so bad, then just throw away that question. Don't need to do it. There's enough questions for you to do. So if you are about to embark on a method, you should always think about how bad do I think this is going to be. If it's going to be really bad, don't even start doing it. Try to look for an alternative. If you cannot find an alternative, skip it first. Right? Don't go into a super long winding path, let's say, of the cosine rules with no idea whether it's going to simplify or not. I also don't know how the cosine rule will simplify. I didn't try. Okay, question 9 is one actual geometry question. And hey, you have a right angle triangle. So I don't really know what the scale of this is going to be. So I will draw something like this that is not too comital. It's a right angled triangle. I don't want it to be, okay, wait. AD equals to CD. Okay, so I need to have my AB be shorter, right? So maybe not like that. Shorter. Give myself some space to put D. Okay, so this seems to be more plausible. Okay, and then now I have AE equals to DE. Okay, another one. These are equal. And then it turns out that CE is the angle bisector of ACB. Oh. Does it look like it? Actually, not that bad. Quite okay. Find angle ACE in degrees. This one here is basically just a config job. By config job, it means that if you recognize that this and this gives you that, you'll be done almost immediately. Now, this and this gives you a cyclic quad. The reason can be summarized in different ways. You could use the angle bisector theorem. You can also just say that why, because of the extended sine rule. Because you know that your A over sine A equals to 2R is the extended sine rule. Therefore, if triangle AEC and triangle ECD have the same circumradius, and they're both going through E and C, then clearly they have the same circle, right? So you can think of it that way as well. But this configuration of equal stuff here and angle bisector there gives you AEDC cyclic immediately. I need to find ACE, so I'll just call the angle X, and then I'll do an instant angle chase. This is an isosceles triangle, so this is 2x, ADC is isosceles. And then by angles in the same segment, this x comes here. So immediately your triangle is just 3x and 2x, 5x equals to 90 degrees. By the time you reach open, for geometry, you will have a mixture, right? There will be a mixture of like questions which are using basic tools, and there will be some of like, oh, you're supposed to actually realize that this thing is the auto center, and the auto center has this property. You're supposed to realize that, oh, this thing here implies that it is cyclic. If you're not so familiar with geometry, try to look for the questions that seem to be more formula-like. This does look quite formula-like. If you try to just do it with trigo, you will also be fine. I'm not going to talk about trigo solution, but essentially, it's also okay to have a mixture where you did a bit of length chasing, and then you realized along the way that, oh, actually, this thing is in fact going to be cyclic. So, okay, I can use that to solve it back to normal geometry. Okay, one more, and then we will take our first break. We started off basically doing the questions about 4:40. So at this pace that I'm going at, we are essentially at a 5 minutes per problem kind of pace, 4 to 5 minutes. Obviously unrealistic because I know how the problem is meant to be solved. But then again, if your aim is to get into round 2, and I said the cutoff is around 12 questions, you literally could take almost 3 times as long as I did per question, and you don't have to do all of these. You can do some of the ones later. So at least for the round 2 cutoff kind of benchmark, it's okay. But as I said at the start, finishing the paper is another issue altogether. That is really, really hard. Okay, question 10. Let x and y be complex numbers. This is a red herring. The question has nothing to do with complex numbers. X and y are complex numbers is almost like the question setter, i.e. me, is not going to tell you whether x and y are real. That's all. It doesn't mean that you're supposed to use complex number methods to do it. So this is just going to be quite symmetric in x and y. And it's hard to tell what sort of identity gets you here. Maybe there is, maybe there isn't. I'm going to usually do this whenever it's symmetric for 2 variables. I'm just going to substitute in xy and x plus y. It will break the symmetry, but often it breaks the symmetry such that with 2 equations and 2 unknowns, I can just solve for a and b. And that would be more than enough to solve the question, because I'm sure I can also write this thing in terms of a and b. So expand this. This tells you that a plus b is equal to 7. Expand this. A squared plus, this is b squared minus 2a equals to 25. This is obviously a quadratic, which I can just solve by substitution, put b equals to 7 minus a inside. Good news, this factorizes. So a is 2 or 6. And a plus b is 7, so b would be 5 and 1 respectively. Okay, then now you just go back in. I think it is almost better to just write this in terms of a and b and then substitute it later rather than to do it twice. So I will just write it like this. Except that I don't need to fully simplify this, right? I'm okay if, let's say, oh, x squared plus y squared squared minus 2x squared y squared. The x squared plus y squared was just now the b squared minus 2a. Sorry, this was the 4 just now, not 2. And then, okay, don't need to expand this already. This is fine. Just put in the 2, 5, and 6, 1 to check what you get. Or if you want to compute a bit more easily, you could technically group the A stuff together because it is also a perfect square. So maybe just so that I have one less thing to count separately later. Okay, so the 2, 6, 1 is going to give me 3 squared plus... Wait, no, 2, 5, sorry. The 2, 5, 1 is going to give me 3 squared plus 21 squared. And the 6, 1 will give me 35 squared plus negative 11 squared. Which sums to our answer of 1796. Okay, so this is up to question 10. We will take our first 5-minute break here. If you have any questions, you can type into the very suspiciously empty chat. And then we will resume with the next section. We'll probably do up to around question 18. Some questions from the chat, which I think I should answer verbally rather than typing. In terms of trig, I don't know. I will say that uh, if we're just looking at the papers, right? For the last few years, the junior paper from year to year changed a lot. The senior paper from year to year changed a lot. The open paper, not so much. Like when I'm talking about it, means in terms of the style, the difficulty, the kind of like the last couple of years have been quite similar. That doesn't mean anything, but it can change. So for any topic, like let's say trig, it can be heavy, it can be light. You want to make sure that at least you know the identities well. So you don't want to fail the questions because you forgot the identities. If you fail the questions because the manipulation is just unmotivatable in that time frame, then never mind. Probably so will almost everyone else. I do think it will definitely be likely that the difficulty is much lower than this paper, but I'm saying likely. I'm not saying definitely because the difficulties usually, if you're looking at it from like a 10-15 year perspective, and it's completely unpredictable. In terms of scores with improvement, basically I always like to separate it into two things, right? The two things are question limited or time limited. If let's say that your score is kind of because I can't solve anything else, right? It means that like I did 13 questions, I did 8 questions, I did 4 questions, I did 18 questions, whatever it is, and then I can't solve any more even though I stare at them. My suggestion is that in the few days, of course, you can start to read solutions or watch my solution to some of the harder questions. But basically, you need to be willing to try methods that you are not sure will work. Right? A lot of times, you are just trying a method that you know will work rather than trying a method that may work. Right? This is just, of course, a very broad statement because it depends also on what type of questions you like to do, what section you're on. But that's kind of what often happens. If it's time limited, then you want to see whether you can find a bit more shortcuts in the questions, such as like I've shown in a lot of these problems how you can look for them. The shortcuts is like before you do something very computationally heavy, just take a while to say, can I do it without that computationally heavy approach? It may not be possible, but more often than not, there will be an intuitive way of doing it. In fact, as a student, I would probably take a lot more so-called speculative assumptions than what I am doing when I explain my problems, solutions, because I need to demonstrate here to you that my question is sound. But if you're doing something, you're just like, I think that thing is quite small. Let me just guess the small answers and then see what happens. Right? This is going to be something that also does happen. Goal at top 30 is generally hard to say. I think that the open in the last 2 years has not been too ridiculous for round 2 by open standards. So you would usually expect that I think 2 complete questions in round 2 should guarantee you a gold. 3 complete questions in round 2 should guarantee you a national team spot and the top 30, unless the paper is very weird. Now, I say that guarantee. There have been years where it's very difficult and it will be lower, but there's never been any situation, as far as I can recall, that 3 questions in round 2 isn't enough for top 30, or 2 questions are not enough for gold, even if you just nice got the cutoff score for round 1. Right? If you got 5 points above the cutoff for round 1, then of course you get a bit more wiggle room there. Okay, so let's get back to the questions. We are looking at question 11, which is a floor function meets graph question. Find the area of the region that is included in here. Now, looking at this, the thing is that floor functions are just approximations, right? It's round down. It means that if my x and y are very big, it's not possible that x squared is and y are equal, as well as y squared and x are equal. Neither is it possible that they're that close to each other. So therefore, I can say in fact that if, okay, first of all, it cannot be negative, right? If you know that these two are greater than or equals to 0, because it's a square. You round down, it's still non-negative. So therefore, you know that your x and y are also non-negative. So that at least throws out the worries about any of the other quadrants. Now, if my x and y are both more than 2, then whichever is the bigger one, it is very clear that the x squared and y are going to be at least separated by, well, 2 squared minus 2. Which means that it will not be possible for these to match. We can deduce that the x and y's must, at least one of them has to be less than 2. But of course, if x or y is less than 2, then the floor of it would just be 0 or 1. So that's the cases that we just need to check. Yeah, it often is the case that the clever questions have very little computation, right? Then the more straightforward conceptually questions are more annoying to calculate. So like this one here is a clever idea, and then the calculation is very little because it's okay. So floor of x is 0. If floor of x is 0, that means that your x is 0 point something. Then your floor of x squared also going to be 0, so therefore your floor of y and y squared are 0. Basically, it's all fine, right? As long as your y is also 0 point something. So that will give you your first region, if you're talking about it as a graph, it's just a square, a 1 by 1 square here. Not including the boundaries, but for area, the boundaries don't affect the total area, so that's fine. If the floor of x is 1, then your floor of y squared has to be 1. I can already use that to say that the floor of y squared is 1 means that y is between 1 and 2. Which, sorry, y squared is between 1 and 2, so y is at most square root 2. Now, if that's the case, then your floor of y is also 1, which will also then make the x in the same region. I'm writing everything out, but half of these steps may be in your head, right? Okay, so this is 1, this is 1, this is, okay, so this is between 1 to 2. Like, you probably won't be writing every single thing out. So anyway, this means that if floor of x is 1, both of them will end up in this second smaller square, from 1 to root 2. Not 1 plus root 2, just root 2. Okay, so your area is 1 plus root 2 minus 1 squared, which is equal to 4 minus 2 root 2. Now, I think it is a good idea to know square root 2 to a couple of decimal places, because your, so square root 2 is 1.414, even just 1.41 is probably a good idea, because it's commonly used enough. So it's just 1.1 something is going to give you your answer as 11. Okay, question 12. This is a question with two simple but unrelated parts. Your function is not like a formula function. Your function just takes in 1 to 40. It outputs an integer, not real, integer. And you're told that f is increasing, as well as that your fx squared is less than or equals to 20 fx minus 26. Now, I actually have to say that yeah, the values again are chosen. You see 2026 there, it always looks like as if I'm just putting in 2026. I'm always choosing it such that I think it's like feasibly done in minimal computational time. So this can give you a list of possible fx because this is for all x. You can, however, generally choose to complete the square for these kinds of things that are for integer values. Right? Rather than have to approximate some more square roots, I just complete the square, and that means that your fx minus 10 goes from minus 8 to 8, remember, integer values. So your fx can be anywhere from 2 to 18. So now that means that you have got your function. The codomain was z, but actually now you know that your codomain can be further restricted to 2 to 18. It's an increasing function. You need to give these 17 values to these 14 inputs, and it's in increasing order. Your answer is just 17 choose 14. Because your choice of values, once you have chosen them, then you know that they have to be given to the inputs in ascending order, increasing function. 17 choose 14 is 17 choose 3. So again, this is not too bad. Yeah, on the topic of of like trying to minimize silly mistakes, I cannot really say that there's a way to eradicate it to zero, for sure. One thing is recognize the kind of mistakes that you tend to make and look out for them. If like you always make off by 1 errors, like then you're like, I look at the counting question, I'm like, I'm going to make sure that I check everything, is it off by 1? Like I'm going to check all the boundaries of my inequalities, like especially hard. If somehow every time when you do long division, you always mess up, then double check. But you can sort of shortcut your double checking by, let's say for computations, just check the computation mod 9. Just check the last digit of your computation. If it's computational, of course, sometimes you can substitute back into the problem, but assuming that doesn't work. And then if let's say that it's just you always read the problem wrongly, then you know that that happens to you a lot. If you keep reading wrongly, then just remind yourself to read the question again. Take a bit more time, never mind. If it's like, I do a bit of everything, then honestly you just need to slow down a bit overall if your careless mistake percentage is too high. I always say that an acceptable careless mistake percentage to me is somewhere about 15% for SMO, because unless you are like doing only like 2 questions, then of course that doesn't make any sense. But if you're doing, let's say, 10 questions or so, you don't want to be making more than 15%. But if you are trying to make it zero, then you're probably going too slow, right? You can accept a little bit of error margin, because even to the first place of the SMO, they also make some errors in round one. Okay, 13. You have a triangle, you have a circumcircle, and you have a diameter. Let's try to draw it reasonably. You can't really draw it to scale, but 3√10, you know that 10 is about 3.1, 3.2. So it should be like between AB and BC. Also, it's quite clear that this BC is a lot bigger, so it should be an obtuse triangle. Now, AD is a diameter of the circle, which I'm not sure if I quite drew it in a very diameter-like way. Let me adjust it a little, and sorry for... Okay. Because I know that if it's supposed to be 90 degrees over here and over here. I'm not sure if I actually need it yet, but that should be true since AD is a diameter. Well, actually, I should draw it, right? I want BCD, so never mind. I'll draw it because this is necessary. There are actually going to be quite a few different approaches that you can take for this. That includes mostly trigo-based approach, right? Because it is possible to use this to find the circumradius, and then after that, from the circumradius, you would know what are these angles here because of just using your cosines, and then maybe you can use the cosine rule and sine rule to get the other lengths and get the area. So that can work. I'll just show another method that I think is pretty nice, which is that in fact, this, if you drop the perpendicular down, would be a pretty useful construction, since I now can technically ignore these two things. Right? To get the area of BCD was not really about triangle BCD, I just need the height. So maybe this height is more meaningful than drawing from D up to BC. Right? BC is 13 already. So I just want to find EF. Let me put the lengths in, I forgot to put them in the whole time. I can use power of a point to do that. Now, before that, the thing that I am doing here, take note that actually this thing here is also going to be perpendicular. You have got various ways of concluding this. It can be just a simple angle chase. Alternatively, we also know that the autocenter, which is somewhere here, when you reflect the autocenter over here, you get to you get to here, right? So you know that all of these are on the same perpendicular line. So that also can be a justification for it being the foot of a perpendicular here. Okay, so what do I now want to do? I said power of a point, right? The reason for power of a point is just because I can get these three lengths just by one instance of the cosine rule, everything will kind of collapse. So let's just do that. Okay, so cosine b is 4/5. So that's nice. This is 4, this is 9, and this is 3. So therefore EF is 12, and your area is half times 12 times 30. Yeah, so again, a slight geometric configuration that we're using, I erased it just now, but I'll just put it back, is that for this diameter here, like why am I doing this is that it looks weird since the auto center here is outside of the triangle, but when you reflect the auto center about the side, it will land on the circumcircle. When you reflect it about the midpoint of the side, you will end up at this antipode, which is opposite A. This point, right, in fact, is exactly what is going to happen. So that is the underlying thing, but it in this case isn't really needed to be used the point H. It's just that's one way of recognizing this thing to be true. Okay, vector question, which is bound to show up somewhere in the SMO. A lot of the vector questions in the SMO are kind of very generic A-level vectors, H2 kind of things, except that they will be chosen such that calculators are not needed. So if you are not yet familiar with vectors at all, I would say just give it up right now. If you are 5 days out, there are better ways to spend your time than to learn vectors which you may or may not be able to solve the potentially one question that is in the round 1. On the other hand, if you are mostly familiar, but it's like I just forgot what the cross product is, then please go and read it, because just like any other specific formula, you don't want to fail a question because you forgot the formula. So UVW are unit vectors. You are given the three angles between U, V, and W. I'm not going to draw it yet. Now, the projection of U onto the plane containing the origin, V, and W can be written in this form. So we understand what, so V and W here, when you say unit vectors and it contains this, you understand it as the position vectors V and W. The origin is 0, so V and W have a 60-degree angle, so that one's a nice angle. So let's say that this is the V and W. Now U is somewhere, don't know where, and then it is being projected downwards. Now we know that cosine inverse of 0 is 90 degrees. So these are both quite close to 0, meaning that it's like your U is just somewhere like kind of close to orthogonal to the two of them, but actually has nothing to do with the question. So let's say that this is my U, and then you project it down onto the plate. Now, I don't want to just cross product or whatever, because I don't know what UVW are. I need to think about what is the nicest way to get it. And I realized that, okay, if I were to, I don't want A over B and C over D, that looks ugly. If I were to just call this thing here lambda V plus mu W, then the difference, let's call this difference vector here just V1 or there's a vector, let's just call it K. Okay, it's also a bad choice for vectors. What choice should I use? S, whatever. Then your S is going to be U minus lambda V minus mu W. Has to be orthogonal. This one is orthogonal to both V and W. Now I can use the dot products therefore and substitute it in. Now V dot V is itself. So got a plus sign there. So V dot V is V squared, which is what? Sorry, yeah. I also do not write vector solutions too often. Again, W dot W is going to be 1. And so the point is that these are known. We know that your dot product of U dot V is just modulus U modulus V times cosine of the angle, and the angles there are known. Right? U and V, the angle is cosine inverse 1 over 20. Cosine of 60 degrees is half. So we can solve for lambda and mu quite easily. This just comes from subtracting those fractions when you multiply one of them by 2 and eliminate. So these are the two coefficients that are in your A over B and C over D. Just nice, these fractions, the components add up to 600. Okay, question 15. There exists a positive integer d such that for all integers n greater than 2026, n to the 26 minus n to the 20 is divisible by d. Find the largest possible value of d. This has been a theme of many problems before about getting like a GCD of infinitely many things, because by some number theory theorem, they are always going to be divisible by something or some things. Now, obviously, it is kind of a bit weird looking at first that why am I making n big? But in a way, n is greater than 2026 is not very important. N is greater than 2026. It's just for the purpose of I don't need to worry about like special cases of like prime numbers that are even or stuff like that. Right? It is often may not matter too much. At least for now, we are not sure if it matters too much. Okay, so when it comes to finding the GCD of all possible things, we can consider the different primes separately. I know that this can be factored into n to the 20 times n to the 6 minus 1. So my question is, which primes can I even look for? Well, if let's say that for any prime p that is in D, I need this to divide for all n, which means that if n is not divisible by p, it must go into n to the 6 minus 1. Now, this will allow me to shrink down my search a lot already, because if I want to restrict the list of primes that I need to check, n equals to 1 tells me nothing, because if it's 1, then that is going to be divisible by p. But I can put n is 2 mod p, unless p equals to 2 itself. So you put 2, and you now know that p must divide 63, which means that p can only be 3 or 7 apart from 2. Now, moreover, you can sort of say that, well, if I have upgraded this from p, I can also say that if I want power of p, the same logic still applies. The same logic still applies that I can always just add a k to all of this. Right? Nothing has changed, which means that apart from 2, I can say that, well, it's not just p is 3 or 7. The maximum that I can look for is 63, which is 3 squared and 7. So I just need to check 2 to the whatever, 3 squared and 7 to see if they can be found inside. But that's both going to be settled by your Euler and Fermat theorem respectively, right? This phi of 9 is 6, phi of 7 is also 6. So phi of 7 is 6 is your case of your Fermat theorem. So it does imply that you are going to get your 3 squared and 7. If your n is not 0 mod those things. If n is 0, then of course n to the 20 will take care of that. So you have confirmed that 3 squared and 7 are really there. Now to deal with the 2, you kind of just use the same logic as well, except that I cannot sub in 2, so I can sub in 3 mod whatever power of 2 that I want. So likewise, if 2 to the k divides n to the 6 minus 1 for odd n. Then put n equals to 3 as your probe for what should k be. I'm not really interested in the value. I just want to know that, okay, so actually if n is 3, that tells me that this only can fit in a 2 cubed. And so I know that k is at most 3. And I know that also n to the 6 minus 1 will be divisible by 8 if n is odd. For a variety of reasons, I can just say that in fact n squared minus 1 is already going to be 1 mod 8 for odd n. So power 6, still the same. So that also works. So therefore your D will get all of these things. Okay, let me switch over again to the refresh my Microsoft Word to the next question. And question 16 is the pretty guessable question, which amidst all of this, I'm glad to say that many of you managed to get this right. It is a pretty guessable question because it is annoying to explain the proof in writing, but intuitively quite, I would say simple, but it is quite obvious what choices to make. Now, for one, the question is asking you to minimize n over fn. So fn is the LCM of the digits. Now, n is already going to be a 5-digit number. So what we want to do is that you definitely are going to put the digits in ascending order to minimize n, right? While keeping fn the same. You also know that your digits should be co-prime. Otherwise, I can just remove the common factor from one of them. Technically from the one that has the lower exponent, so that the LCM doesn't change, but you're making n smaller. So if you want to have digits in ascending order that are co-prime, of course, that is not to say that we will pick 1, 1, 1, 1, 1. Obviously, that is bad. We are not disallowed for repeating digits. It's just that as long as I can maximize this, I should, right? For example, if I were to now change this last digit to 9, that is making it smaller. So therefore, I know that the maximum that I can take is if I were to do it in a greedy fashion, which is 9, 8, then 7, and then 5, and then at this point you used up all the factors, so just 1, right? And put them in order. So just this will be, not too surprisingly, the optimal value of choice. This is the kind of question that can also appear in SMO Junior Round 2, that a lot of people will end up getting like weird partial marks because they didn't explain exactly what they were doing. But in the SMO Open, you probably shouldn't worry too much about explaining exactly what you're doing, as long as you know why you're making that choice. So make the LCM big or make the numbers small. If any of the digits are repeating factors, then you are wasting that increase in n or no increase in the LCM. So this is what you expect to happen. Now, 17 is actually related to one of the questions that I have put in my class a couple of times, because I just think it's pretty fun. And so it's also a tiny reward for those of you who are in my lessons who have actually read through the questions properly. You have A, B, C, D with coordinates as such. So it's just like a diamond shape like this. You have a circle with radius square root 45, which is going to be 6 point something. So just draw a bigger circle around it. P is somewhere on this circle, and you want to make it have the largest possible value of this. Now, I actually wanted to make this question also guessable. And some of you managed to guess that this is 2026. So, 恭喜你, yeah, if you guess that it's 2026. If you went one step before that, and I'm not going to just guess it's 2026 lah, but I want to properly solve it, you can say that it's probably going to be this one or this one. And then the rest are the same by symmetry. And then you check both of them, which is possible to get the distances by, let's say, Pythagoras or the cosine rule or something like that. Can. It turns out that this is the one that works. If you pick the other one, unfortunately, you'll get the wrong answer. You will get 2024 instead, right? If you pick the other one, yes. But let's say that you want to know why, and you would like to get the most efficient way to do it. The approach is by complex numbers. Take this as an Argand diagram instead. Now, when we say the maximum possible value of this as a product of distances, convert it to complex numbers, and it becomes a product of the moduli of these things. Just expand it out, and you get modulus of p to the 4 minus 1. Now, we know that the modulus of p is square root 45. That does not mean that you have to sub in for square root 45 for p, right? So that would be assuming that is this point, which means that we are doing the same assumption as before. What we're saying is that actually by the triangle inequality, this is the maximum when p to the 4 and -1 are in the same direction. So equality actually holds if the argument of p to the 4 is going to be negative real, right? So it's pi, i.e. your argument of p is pi over 4, 3 pi over 4, plus or minus. So that is the 4 points that it could be located at. So a bit of a surprise here, if you have not seen complex geometry before, it is not like you will use this very indiscriminately. We have done a lot of coordinate geometry where we have never mentioned complex numbers, but many things do work well in complex numbers, including regular polygons being roots of unity, including, let's say, if you have rotations or reflections and some other things. If you're familiar with complex geom, you will know there's a long list of nice things, but those are the first few. Okay, so question 18. One more before we take our second break. I think question 18 is sort of the second, maybe the third more computationally heavy question that we actually have. So the out of everything, the number theory one just now was also a little bit computationally heavy, but that was just how number theory works. It's not because it is pointless calculation. This one is a little bit grindy, but it's meant to be easier, and it did turn out to be one of the questions that had the highest solve rates towards the second half of the paper. That's because if we have an m by n grid, most of us will know how to count squares and rectangles. So it's essentially do that first and then solve whatever Diophantine comes after. So let's just do that very quickly. First of all, we know how to count rectangles. The number of rectangles, as always, is just choose two vertical lines and choose two horizontal lines. So m plus 1 choose 2 times n plus 1 choose 2. Squares, unfortunately, you don't really have a better way than to just write the summation down. It can be simplified after you've written the summation down, so we just need to see what it does. Okay, so I will write it as, let's say this is m and n, where without log m is more than n. The number of squares would be mn 1 by 1s, n minus 1, n minus 1, 2 by 2s, and so on, until n will run out first when you go to the n by n squares. Right? So n by n squares, you just get m minus n plus 1 and 1. Okay, so this is what S is. We certainly will need to find a good way to express this both so that we can see whether anything simplifies in the fractions. So I'm going to just write the summation from 1 to n. There are n terms. Let's use k. So once again, we have a very similar kind of thing to what we had before in the summation. And then k squared summed up is your n plus 1, 2n plus 1 over 6. This is great because I can see that, n plus 1 times n over 2 is n plus 1 choose 2. So if I can factor that out, not so bad. Okay, so this is S. Now we put in the ratio. So the n plus 1 choose 2 disappears. I'll move the 3 on top. Make sure my m and n don't look the same. So I can get rid of the m. Now you notice the n is just a free variable. I can just let the n be whatever I want because it only appears once. So the bigger issue is, can I make the top have okay, if I cancel off the 3 and move the 2 to the other side as well, means it will be 333 over 100. Like I said, I don't need to solve this like a Diophantine where I do something complicated. The point is that n can be anything I need it to be as long as it doesn't go past m, which should not be very difficult to do. I just need m plus 1 to be a multiple of 333, which is 37 times 3 squared. So it is quite easy to see that to get 37 to appear and 9 to appear, you just let m be 36, m plus 1 be 37. M plus 1 will be 36 times 37, so 3m minus n plus 1 should be just equal to 100, and you end up with n equals to 9. Okay, sorry, not over 125, thank you. But it ends up being back to 100 again after that. Yeah, so because this 36 here, this is 4 times of that. So it'll be 333 times 4 is going to be this, so this is 100. Okay, so at this point, again, we will take our second break. Then in about 5 minutes or so, we will come back and look at the remaining 7 problems. Not all of them are hard, but certainly a few of them are definitely hard. Okay, we will carry on with this final section from 19 to 25. In terms of time management, right, which is a good question, would say that first of all, we don't know exactly what the round two cutoff is. You can kind of sense whether the difficulty is higher or lower, but we cannot really be sure what the cutoff score will be. Uh, I think when you're doing a question, don't worry too much about the big picture, like time frame as you're doing it, right? You don't want to rush yourself until you make mistakes. But at the start, I always say look through all the questions, and perhaps what you can do is at the start, if you're hoping for round two, like circle at least somewhere around 10 questions that you think that you should be able to do, in the sense that you know roughly that the method is something like that. I just need to do some calculations and some things, or it looks simple, right? It's nothing wrong to pick something that looks simple. And hopefully out of that 10 questions, you would have been able to do like at least 7 or 8 of them in the first hour, if not all 10. If the paper is easy, you probably can maybe find more than 10. But you want to be able to get about halfway to your target within 1 hour. That's usually how it works, because after that, things start to slow down because you are tired, the remaining questions are harder, and you will need to read some questions that turn out to be too hard and you skip over them, right? So within 1 hour, you would like to be at least halfway to whatever your target is. And for round two qualification in the last few years, if the cutoff was 16, then you want to have done like at least like 8 questions by at 1 hour in. So that would be the ballpark. Okay, so let's keep going and we'll look at question 19. Each digit of a 14-digit number is from the set 1 to 5. The sum of any two adjacent digits is co-prime to 6. What does that mean? That means that not divisible by 2 and 3. What does that mean? That means that if I have got 1, 2, 3, 4, 5, I can actually say that, well, let's just look at, okay, what can be next to 1? None of them can be next to themselves because it's not, the sum of two adjacent digits is not even. So you just check, okay, it cannot be next to 2, cannot be next to 3, it can be next to 4. Then 4 can be next to 1, as we said, it can also be next to 3. 3 can be next to 2 also, and then 2 can also be next to 5. So 5, that's it. 5 and 1 cannot. So that's actually equivalent to saying, just in this line, start somewhere, and then just run back and forth along this line. So start somewhere on this line and run back and forth along this line. It's not the most inspirational sounding solution, but it actually can be good enough, because the line is short enough also that it is not so hard to compute. The key is that you know that you are alternating between odd and even numbers. So if you're alternating between odd and even numbers, let's say that I start with an even number. I've got 2 choices for the first number. The next move, there's 2 choices, but I don't want to do it that way, as the next move has 2 choices, then the next move has 1 or 2. Oh, broken already. No, I actually want to say that the next 2 moves have 3 choices. Because this is the only combination that doesn't work for 2, this is the only combination that doesn't work for 4, and after 2 moves later, I'm back on an even number again. And both even numbers by symmetry behave the same way. So I've got 3 for each subsequent pair of moves. 6 pairs of moves, and then times 2 again. The other case is you start with odd. But actually, if you start with odd, that just means you end with even. And if you end with even, by symmetry, it's also the same. So your answer is just 2 times of that. This is not like I'm saying a super easy question, right? But it's the kind of question that in SMO Open, I think you would like to be able to do it. For let's say a round 2 qualification or a silver, you like to be able to do it. But it's a question 19, which means that if you went in order, you may not even see it. So that's why looking around is that this doesn't look so bad, because some of things co-prime to 6 is very restrictive. Probably there's only a few ways. Then you actually look at it, really there's only a few ways. So this one was not too bad. 20 is also not too bad if you have the intuition of AMGM. The intuition of AMGM is that you would like to get a minimum value. So for it to be a minimum value, and the whole thing is homogeneous degree 2, it means that I suspect it is greater than or equal to some multiple of xy plus xz plus yz. I also suspect that because it is not going to be that nice integer values xyz satisfying this, perhaps, it is at least not obvious if that's the case. In order to do this, it means that I would like to AMGM using the x and y's, the x and z's, and the y and z's. In turn, that would require me to have, well, by symmetry, the x and y's have the same coefficient, so it's probably going to be something like this. You take the same amount of x and y as your first equation, you take the remaining x's and half z squared, and the same for the y. Right, so this is very typically how we use AMGM for degree 2. We can say this, and the only thing left is, okay, for what k will AMGM give me the same coefficient? I will need the product of these and the product of these to be the same. Which you can solve, just gives you k equals to 2. So you're reverse engineering to find out, so what is it? And it turns out that, okay, 2x squared plus 2y squared by AMGM, or you can say completing the square, but that is just going to be way too like facetious to say that I discovered by completing the square. No one is going to discover by completing the square. Although technically when you are doing AMGM on 2 variables, it is completing the square, no doubt. But this is not a combination that you are going to generate yourself, right? Too random. Okay, so you sum it up and you will find that your minimum value is going to be 4 times 15 equals to 60. Equality can hold, you just need x equals to y, and this half z squared equals to those means that z will be 4 times of x and y. It's the equality case based on using your AMGM or completing the square. Okay, the last few are legitimately hard in different ways, but not equally time consuming at all. They are hard because either you need to know something, or you need to do something, or it is very easy to mess up, but not all three of those at the same time. Question 21 is probably the one that is the weirdest looking. It is probably the weirdest looking one. These are absolute values. These you kind of think that they can telescope and yet not really telescope. Even without absolute values, the numbers 1 to 399, a bit weird. Now, the intuition for this would be as follows. Despite the weirdness of it, it is piecewise linear. Right? The absolute values are just going to split it into pieces, but it is piecewise linear in n. If it is piecewise linear in n, what that means is that you can look at the graph as being, well, when n is very big, all of these absolute values disappear. The gradients would be just, 2 over this, 2 over this, 2 over this, all summed up, right? Which would telescope, and telescope to 2 over 100 minus 2 over 300. When n is very small, very negative, then the reverse happens because the absolute value flips everything. Otherwise, it's sort of going to be like mixing all of them up. So the graph is essentially going to look like that in some way, where these are all a bunch of straight lines, but the gradient is gradually increasing. To get the minimum value, you want the stationary point. That is really it. Even though it's piecewise linear, you can still talk about a stationary point, except it's technically a stationary region. So it's calculus inspired. You want the stationary point, and you notice that all of these are going to change direction at different places. Right? When, let's say, n is less than half, your gradient is all negative. And then after that, you are going to flip them one at a time. Right? At some magic spot, your gradient is going to be until 2 over something, and then minus the rest. Now, I want this to be 0. So that is really just partial fractions. We know that if you were to add all of this up, as mentioned earlier, that does telescope. I 1 over 75. So therefore, I want the front part, let's say if I were to stop at this some x plus 1. Say. I want the front part to be half of this so that the back part will cancel off. I want this to be half of that. And so if you solve, you will end up with, okay, so this x plus 1 is just 150. Meaning that your turning point should be that term where this is 149 and 150. Right? This would be the turning point between this and the next one. You would like it to be such that your 2n is between, if this is the turning point so-called where your sign changes, your 2n is between 99 and 101, which gives you n equals to 50. Okay, so this is a very unusual formulation, but basically what you are looking for is the weighted median. That is what it can be also referred to. You are looking for it to be the point where it is going to cover half of the weights of the gradients, and that will be the place where it is an equilibrium and gives you the minimum value. YouTube keeps randomly glitching and showing me that I have one viewer some point, and then that sounds very depressing. So I hope the paper is not that scary. I also don't think it's one viewer. It's just showing me weird stuff. Okay, question 22 is just like in the senior paper, something to put a bit of a smile on your face, and then after it's like, yeah, but actually what am I supposed to do with this question? Uh, so there are 8 special locations with some shuttle buses arranged, and uh, you would like to be able to have a contingency where if any one of them is closed, then you can sort of take a loop that goes through all the remaining places. So what is the minimum number that you need in order for it to be arranged? This is the round 1 style so-called soft graph theory, because it is true that the best way that we can describe this is as a graph. That there are 8 vertices, and you want to draw some edges. You want to draw some edges such that if you remove any vertex, the other 7 will have a cycle. Now, technically speaking, you can already say that clearly I need to have at least 7 form a cycle, like one cycle, right? Let's say if this is removed. So I've already got a cycle here for these 7. The question is, how many more do I need to add such that for any other one being removed, I will be able to still have a cycle of, well, all the other 7. So firstly, I would say that, okay, what about if now I remove this guy? A decent way of completing the cycle would just be to do this. But it doesn't seem like it is going to be a good idea to just connect to everything else. Right? That is probably a little bit overkill. So I'm going to actually sort of then do what I would probably do in the contest, which is to say that, okay, stop. I don't think I want to just guess and check a graph. That sounds too scary and also too time consuming. There must be a very simple explanation for this, right? And uh, what would be the most trivial bound I can come up with? Well, a trivial bound is that for every of them to have a cycle, each vertex has degree at least 2. Wait, the vertex at degree at least 2, even after you remove any of the other vertices, there must still be a degree 2, so plus 1. So each vertex has to have degree at least 3, and if each vertex has degree at least 3, then the number of edges is at least 3 times 8 over 2 is 12. Right? This is a trivial bound. It turns out that you can get 12. It also turns out that, like a lot of the past year SMO open problems, almost every year there's a question where you can get a bound and it's like the construction actually just it's too specific that it will take too much time. But because the bound is there, you can guess it with a pretty high degree of certainty that you'll be correct. Now, I will just say that the solution, this construction, is actually quite famous. I think it's just called a Mobius graph. If you know that, good for you. And I can sort of draw a nice depiction of it if you want, just to show how it looks like. But as we know for graphs, there are many ways to draw isomorphic graphs. So if it looks different, that doesn't mean it is wrong. So I'm just showing how it should look like. That's the Mobius graph that will give you a construction for 12 edges. So for combi questions, a lot of times this is what you can do for the optimization combi. Either you just come out with a good looking construction, you try another couple of minutes and say that the SMO construction can't be that hard, it's probably correct. Hope for the best. Or the reverse, you look at it and say, you just come up with a simple bound. And then it's like, the SMO bound cannot be that complicated. Like if I got this bound, probably equality can hold. So I won't bother constructing it if I have no time. Oftentimes it turns out that the trivial bound or the most natural, clever construction is going to work. And that is indeed the case here where the trivial bound is good enough. Okay, 23. The answer to 23 is 0. And I think many of you guessed 0. I wanted to kind of leave a guessable question there. And some of you guessed it simply because of like, you see so many zeros, I don't know what to do, I guess 0. 0 can be an answer, nothing wrong with that. Some of you guessed it because it's like, what kind of garbage is the 9th derivative of g and the 7th derivative of g? Okay, so there is actually just an idea that is specifically meant to be used here for those of you who, in your A-level math, I am not sure whether your H2 math teacher has mentioned. The idea is that your g of x, if you look carefully, all of the functions are very unrelated to each other, except in one way. You see a lot of squares, you see all this. Gx is an even function. If G is an even function, then its Maclaurin series, which is related to all these nth derivatives at 0, right? The Maclaurin series only has even powers of x. That's where the even and odd function comes from, right? Even function would be polynomials with only even powers. And odd function, only odd powers. We also know that the even powers of x being the only ones tells you that the odd coefficients are 0. Which means that the odd numbered derivatives of, just write it, g to the 2k plus 1, 0 is 0 for all k. So that is basically the property that is being used. That's the other so-called calculus question. That I think calculus questions being in play means that anything that you learn in A-level calculus is in play. That will also include your Maclaurin series. Okay, 24. Don't worry, I am not going to ask you to pay me 2 to the n dollars after asking questions. You can continue to ask. This is a very weird PIE. So we have had maybe a handful of questions that are computationally intensive. PIE is always computationally intensive. There's no such thing as a PIE question without. And all SMO Opens have, on numerous occasions, it's like, oh, PIE, in order to make sure that you really understand it, I need to have 4 sets. It's 4 sets is always computationally intensive. So that is also indeed the case here, but I wanted to make sure that we're at least doing something a bit more clever. So the idea is just that you have weights, right? So if it's exactly 1 student, then 1 student pays $2. Exactly 2 students, the 2 students pay $4. And then for 3 students, 24. And then for all 4 students, 64. There is nothing really nice about this. This is just meant to break symmetry so that you actually need to ask yourself, what is an efficient way where I can find out all the number of things from 1 to 500 which are divisible by exactly 1, 2, 3, or 4 of these. Now, the computation wise, 500 is chosen to at least make things a bit better, but it still needs some time. So we're just going to quickly speed run through the things that we want to get, and then I'll explain to you how to combine them. Okay, for PIE, the point is that I don't want to have A but not B but not C and D. A and not B and C and not D. Not A, not B and C and not, I don't want that, right? The point of PIE is just that I only want to have unions and no negations. Yeah, so I want you to have intersections, no unions and negations. So A, just 500 over 2, B, 500 over 3, over 5, and then over 7. The point is just that when you're doing the floor over something, you can use the preceding values, right? So they do shrink. That's the sort of consolation. So let's say A and B, you can take the B one and divide it by 2 again. A and C, you can take this and divide it by 2. A and D, you take that and divide by 2. All of this, you round up. So let's just speed run this. It's not very exciting. These are pretty small, so again. Now, as I'm writing all of this for your benefit, of course, if you are writing all of this, please don't mess it up, otherwise you will be very angry. But more importantly, do it how we're combining these. If you don't know how to combine this, then it will be a colossal waste of time. We can't draw Venn diagrams because it's 4. So you do need to have an understanding of what we're doing. Essentially, I can just go from right to left. Right? So the two students here will have just, sorry, the 4 students, there will be 2 lessons. For exactly 3 students, it will be this minus 4 times 2. Because I have to remove this from all of them. Okay, so this part is still okay. Now the question is, how do I deal with the 2 students and the 1 student? Definitely I need to include all of these. I need to throw away these ones are counted 3 times in here. So A and B and C are counted, let's say, in 3 sets. But not really these ones. It's actually these ones are counted 3 times. Right? It's not the at least 3 here, it's the exactly 3. And these ones here are counted all 6 times. So 136. And then finally exactly 1. You say that the 4 has been counted 4 times. The 3s have been counted 3 times. And the 2s have been counted 2 times. Okay, so then just put all of those in. So this is by far the most computational problem. Weirdly, quite a lot of people chose to do this question. I don't know why. He actually put this question here as a warning of like, this is the kind of problem that even if you know how to do it, please leave it for last because there are literally 100 different things that can go wrong in here. But quite a lot of people chose to do it. Quite a lot of people ended up with answers that are close enough to the answer that I think you did it seriously but made a mistake. So sorry, I can use a mock paper to kind of try to teach a moral value, which is just as you shouldn't skip questions just because you don't immediately know how to do them. You should also not do questions just because you think you know how to do them if you can imagine that the method is going to be pretty nasty. PIE is just like that. Yeah, I don't know how long ago the comment was, whether it was in this question or previous question, but yeah, none of these questions at the back are going to be things that can be asked for junior for sure. Some of them in front, actually, yes, but most of them, no. So if you're doing junior or senior and you're just watching this, don't worry. Your papers are definitely not going to be nearly as difficult as this. Okay, last one. The last one, this point P is known as the Brocard point. However, you do not need to know any properties of the Brocard point to solve this question. And not only that, I would say that you have had SMO questions in the past that have basically asked this without acknowledging it as the Brocard point, and maybe they just use like a different set of angles. The logic is basically the same. So I'm going to just finish on this. Technically, it is going to be an obtuse-ish triangle. And I will try to eyeball a reasonable location of P. Although from the tangent theta, you kind of suspect that this question is meant to be done in a trigo way, and therefore we don't worry too much about whether our diagram is to scale. So my idea for getting tangent is that I need to have a sine over cosine, because there's no meaning of tangent in a direct application for this triangle. Therefore, I should try to use my sines of this angles theta and cosines of this angles theta in some kind of a coherent way. Now, first of all, I am going to use area so that I can have sine of all of them put together. So I'm going to add up these three smaller triangles. All of them will have half times something sine theta. I'll just write it like this, although we do know that we know what A, B, B, C, and CA are. I will put it in later. I also know that I can find the area of ABC by Heron's formula. So I have this for sine. This is only useful if I can get something similar. So I'm going to try to use the cosine rule as well on these three triangles to make PA times AB all this appear. So we will go again on the cosine rules. See what happens. We are not sure. Okay, so I see PA times AB cosine theta. I know two more of that will appear. The question is, do the other stuff cancel? Because remember, I don't know what PA, PB, and PC are. Otherwise, I would already just be able to use the cosine rule and get the answer straight away. Okay, so I got these three, and I realized that, oh, that's not bad. If I were to just add them, all the PA squared, PB squared, and PC squared will cancel. And this thing appeared again. So great. It means that if I just took the two equations and divided them, that actually gives you, well, it is a property of the brokat point. Right? So if let's say that you knew the brokat angle satisfied this, good for you. I don't think too many people would know that. But otherwise, yeah, the rest of this is now just use herons to get the area of ABC, and then AB squared plus BC squared plus CA squared is also there. I have gone through an unnecessarily large amount of trouble to make sure that the area is actually nice. Semi-perimeter is 84. So by herons, SS minus AS minus BS minus C. You will end up with all of the factors can pair up. You will get an 84 times 11. And then the other one, the sum of squares, no choice. Right? You do have to compute that as well. So therefore, your tangent theta I asked for 20260, right? So that's going to give you your answer as 2 times 4 times 924. Yeah, these are the kinds of useless things that I do for setting papers, which is to try to solve Diophantines to find a way that you have a triangle with somehow the sum of squares of the lengths is a multiple of 2026 and the area is an integer, just so that we can make the question look a bit nicer. Okay, and somehow we have successfully, well, more or less met our target time of 7:15 with a bit of fast forwarding of the computations towards the end. Now, I say again that my objective when setting a paper is slightly different from the actual SMO. I am not actually selecting the people to take round 2. I am not actually giving awards. I do want it to be interesting, and I want it to be interesting even for like the top 10 to 30 people in Singapore. The SMO round 1 should not be interesting for the top 10 people in Singapore. That would just mean that it is way too hard, right? Hard SMO. It is therefore usually boring for them, right? I want to make it interesting for everyone, which by virtue of that means that the hard questions can be really hard or unusual. But if you are not concerned about getting top 10, you probably aren't going to worry about getting every mark. You're just trying to get into round 2 and do well in round 2, right? If the exact score in round 1 only really matters if you're aiming for the top few places. So don't worry too much about the few hardest questions at the end. There are just some ideas that I wanted to share that I think are interesting, but maybe 1 or 2 of these are not computationally very feasible in the contest time. At the same time, please do not take away as so this paper is just completely unrealistic. It contains 1 or 2 features that are unlikely to be in the SMO, but if we're talking about, let's say, the first half of the paper, every one of those questions could very realistically appear in the SMO in those very positions. It is only that the SMO tends to have like easier questions scattered around or guessable questions scattered around. More than I did have in my paper. Okay, so just like I said earlier on, if you have any questions right now, you can just let me know in the chat. If you are otherwise too brain dead to think anymore, then just feel free to leave first. All the best for the actual SMO. And you can always leave some comments when this video is up if you realize retrospectively there's anything I didn't say very clearly. I'm sure that after 3 back-to-back streams, I said some weird stuff, right? So if I said anything wrong, just do let me know in the comments and I will correct them. Okay, so otherwise, thanks to all of you who are here or watching this back on recording, and I will see you in a few days' time after the actual SMO. Okay, so bye-bye for now, and hope that you had fun despite the trauma with these hard SMO papers.